Got a roller coaster, and the roller coaster, as you know, has a motor on it that drags the whole train or the carts up to the top of the track where it begins its descent and starts the thrilling part of the ride. So the motor part has to do a significant amount of work to overcome friction, and there's lots of noise and sound and heat generated as this motor is grinding away. And in this particular case, this motor consumes 1 million joules of energy. So the motor is consuming electrical energy, all kinds of things, as it's climbing to the top of that track. So the motor drags this roller coaster all the way up to the top. Remember, there's lots of losses on the way up, lots of energy being removed due to heat and sound and friction, etc. And when this roller coaster is at the top of the track, because it's gained a little bit of height, it now has excess potential energy. It has gained 400,000 joules, in fact, of potential energy right at the top, right before it begins its descent. Now, question A, what is its kinetic energy at the top? Well, if you look at the question, its velocity is 0 at the top. So since kinetic energy is 1/2 mv squared and v is 0, at the top you're not moving, so you have no kinetic energy. Question B, what would the useful energy be during its climb to the top? Well, since the point is to lift the roller coaster so it can start the ride, the useful energy is potential. So the useful energy in this case is 400,000 joules. That's the point of that motor trying to drag that coaster all the way up. Question C, how much energy was lost due to friction? Well, there's other energies involved. We mentioned noise, for example, but if we assume a majority of it is friction, the roller coaster started with 1 million joules of energy, and by the time it dragged that coaster to the top, 400,000 joules was left over as potential. That means the rest was kind of lost as heat. So this 1 million joules of electrical energy being consumed by the motor went into potential energy and some sort of thermal energy, some sort of heat energy. Those two things must add together to make 1 million. So if we do a little bit of subtraction, if I take the 1 million and I subtract 400,000, it looks like my thermal energy produced was quite substantial, 600,000 joules of energy. Question D, calculate the efficiency. Well, efficiency is like a test score. How good is this roller coaster? So it's useful energy out divided by my overall input of energy times 100 to get a percentage. Useful energy out was 400,000 and it was all potential. My energy in was 1 million. And when I take that and multiply it by 100, it is 40% efficient.